Hello everyone and welcome to this video. In our previous video, we studied the fundamental theorem of arithmetic. Now, we will study theorems related to irrational numbers. You all know that real numbers are made up of rational and irrational numbers. Dear children, can you sort these real numbers into rational and irrational numbers? Well done! The numbers in the first column are rational because they can be written as P over Q. And the numbers in the second column are irrational because they cannot be written as P over Q. Let us consider an interesting fact. Let's divide the number 64 by 2. We get 32 as the answer. Can you guess the square root of 64? Absolutely right. It is 8. Is 8 divisible by 2? Yes. If 8 is divided by 2, we get 4 as the answer. If we continue to do the same with other numbers, what do you observe? Based on these examples, we can say that for a positive integer a, if the power of a is 2 and it is divisible by any prime number, say b, then the number a will also be divisible by b. Come on, let us consider the square root of 7, which is an irrational number. Suppose that the square root of 7 is a rational number. Therefore, we can obtain two integers a and b such that the square root is 7 is equal to a upon b and b is not equal to 0. Suppose a and b do not have any common factor other than 1, where a and b are co-prime. By squaring both sides and rearranging, we get 7b square is equal to a square. That means that 7 divides a square. Therefore, 7 will also divide a. Suppose, when we divide a by 7, we get c as a quotient, where c is an integer. Putting the value of a in equation 1 and solving, we get b square is equal to 7c square. This shows that 7 divides b square. Then 7 will also divide b. According to the given irrational number square root of 7, we get two results here. Thus, we know that a and b have at least one common factor and that the common factor is 7. Note that we had assumed that a and b do not have any common factors other than 1. Whereas the opposite or contradiction of this is obtained. This contradiction has occurred because we have made an incorrect or erroneous assumption that the square root of 7 is a rational number. Therefore, we have proven that the square root 7 is an irrational number because we found a common factor other than 1 in a and b. In this video, we studied theorems related to irrational numbers. In the next video, we will see examples related to this. We welcome you to this video. In our previous video, we had discussed theorems related to irrational numbers. Now, we will see an example based on this. Riddhi and Nidhi were discussing something between themselves in the class. When the teacher came and asked them, "What are you discussing?" Riddhi states that 5 plus square root 7 is a rational number, while Nidhi says that it is an irrational number. The teacher asks them to explain why 5 plus square root of 7 should be a rational number, or why should it be an irrational number. Nidhi assumes that 5 plus square root of 7 is a rational number, which is written as P upon Q, where P and Q are integers. On rearranging equation 1, we get square root of 7 equals to P minus 5Q upon Q. Since you will remember that the difference of rational numbers is also a rational number, we can say that since P and Q are rational numbers, then P minus 5Q upon Q on the right side is also a rational number. But the square root of 7 on the left side is an irrational number. But this is impossible because irrational numbers cannot be equal to rational numbers. Hence, Nidhi tells Riddhi that 5 plus square root of 7 is a rational number is a wrong assumption because what we have obtained here is contradictory to it. Hence, we can say that 5 plus square root of 7 is an irrational number. In this video, we saw an example based on theorems related to irrational numbers. In the next video, we will see some common mistakes that are observed while solving these types of questions. Which of the following statements is true for 3 square root 17? Pause the video to solve the question, solve it, and then match your answer. Let us first assume that 3 square root 17 is a rational number. So, we will write it as follows, where P and Q are co-prime numbers, and P and Q have no common factors other than 1. If we rearrange this, we will get square root of 17 is equal to P upon 3Q. You may remember that the division of rational numbers is also a rational number. Thus, we can say that since P and Q are rational numbers, then the value on the right side, which is P upon 3Q, is also a rational number. Therefore, the square root of 17 will also be a rational number. Can you write square root of 17 as P upon 3Q? No. The square root of 17 cannot be written as P over 3Q. That is, it is an irrational number. This contradiction was caused due to our misconception, because we considered the square root of 17 as a rational number. Therefore, 3 square root of 17 would also be an irrational number. Hence, option 2 is the correct answer. If you have chosen the first option, it is a good try. But this answer is wrong, because if you rearrange it, you will get square root of 17 equal to P upon 3Q. You have determined that on the right-hand side, P and Q are integers. So P over 3Q will be a rational number. Hence, on the left side, square root of 17 should also be rational. But you missed out the fact that square root of 17 is an irrational number and no irrational number can be equal to a rational number. Because of this, your answer is wrong. So hopefully, you must have understood why the second option is right in this example and why the first option is wrong. Teachers can also test the understanding of students in the class